Dear friend, this is my tutorial 13.1. So this is the extension of previous video. So last video I told you how to make in-car file for AIMD simulation and submit the calculation. So in this video I'm going to tell you how to extract the result from the AIMD output files. So let's see. So this is the folder I have completed the AIMD simulation for the graphene supported FE system. So first we need to convert this xdatecard file to PDF file to use a VMD software. So first we will see this, we will do this. So now you type VASPKIT. Then you can see here 72 molecular dynamics kit. So type 72. Then you can see different kind of things. First we will convert our AIMD trajectories of selected atom with the PDF format. So we can now convert into the PDF format. So you can type 737, okay, 737, just enter. You will get this second option. So you can select one, okay, select one. Then you can type all. Then you will get data for all. That's all. So I think how many frames you want to skip, I will always put 0. Here also I will put 1. That's all. Our AIMD trajectory PDF file created. So we can use this file to plot bond length versus time. So this is a AIMD trajectory PDF file. So next one is we need that RMSD. So for that again click VASPKIT, go to 72, and you can see here mean square displacement and mean square displacement using FFT. I recommend that they mention, so I will use this one only for my calculation. So you can also type 722. Here also you type 1. So you can type your number of which atom you want. So I will type if you see here our output file means so we want only nitrogen and iron atom, okay, we don't want any other atom for RMSD. So just we type our nitrogen space and Fe. So these two atoms for enough, that will take care of this. So just enter. So here also I will put 0, don't want to skip. So if you are using 6000 steps, so that time you can skip 1000 steps like that. Here also put type 1. That's all. Return MSD data and diffusion coefficient. This is the very important file. We can plot our RMSD VAS time. So that's all. You can use this VASPKIT to extract this result. So I think we have got the two results. So AIMD trajectory file and so MSD dat file. So you can copy this So this is the two file we want to plot the AIMD result. So first I will show you trajectory things. So for that we need VMD. So you can download yourself VMD from the website and install it. So this is the VMD. So we want to open this file into VMD. So go to file, new molecule, not new molecule, otherwise you can also drag. So after dragging, that will run all the 5000 steps. So you can go to here, display, orthographic, graphics, reference station, go to bond or CPK, then close it. I think 5000 steps over. So if you want, you can also see. So from this here you can start from 0 to, you can see the, I think we have did the 500 Kelvin temperature. Some initial 1000 steps you can see the more fluctuation. So after that maybe the bond length are somewhat stabilized. Yeah, just you can see everything. Yeah, it's over. So we need to get the bond length of this 4 connection with the iron atom. So we will start with here. Okay, so for that so this is the thing. So now you can press 2. So that time you will get that plus arrow. If you type if you press 2, you will get this kind of plus arrow. So now you can select your bonds, whatever you bond want, you can select it. So we want only this 4 nitrogen with connected with Fe. So you click here, this is one bond. So click here, click here, click here, click here, click here, click here. Okay, we have selected 4 bonds. Okay, so just to go here, graphics, maybe labels, I think more things is there. I think we did something wrong. Just you select everything. Delete we will do 1 second. So you type, already we typed that 2. So select this one, 1, 2, 3, 4. So this is the thing. So sorry, here atoms that we need to mention bonds. Okay, if you see here, we have selected 4 connection with Fen atom. So this is the things. If you want to see graph also, you can see graph. So you select this one, you can see preview graph. So likewise, so if you want, you can close it. So the second atom, if you want, you can also see graph. So likewise, this is the 4n with 4n connected with the Fe atom. So we will save one by one. So be sure first your atom is there, you need to convert into change into bond, then you will see the bonds. So you go to graph, so save your files. So you can make the numbers, maybe that will be very easy to understand. So first one is, we have clicked this one. Okay, so you see the numbers of this atom is 67, 71. Okay, this is 67, 71. Okay, so first two what we selected, '67. Okay, type 67 N to FE, save. Okay, second you select, so second atom number is 69. Okay, you can save 69 N to FE. Okay, third one is 70. You can click save, 70 N FE. And last one is 68. Then save. Yeah, so like that, if you want any other bonds, you can mention in that VASPKIT, get that bond distance of the systems. So that's all. I think our files are saved. So now we will plot our result, the bond length versus time. Okay, so just open one file. This is earlier I did, so just to close it, that no need. So you can close these files, no need this graph we need. So first 67 you can drag, you can click OK. So finish it, it will come your result. So then add additional columns. This is a 67 NFE. This is 68 NFE. 69 NFE. 70 NFE. Okay, so first one we copied, then we need to copy the second one. So just OK, finish. So this is 68, just copy paste, make it one Excel sheet. Then 69, and also copy 69. Okay, then delete this one. And 70, finish it. So that's all our 4 bond distance results we have uploaded into the Excel. So just we can plot, select this 4 column, go to plot, and plot line. So we'll get these results. So I will tell you how to arrange. So you can 3 mention, we can also put one, this also minus 3. Oh, minus 3 is too large. You can do 0. I think that's enough. 0 or 1. So adjust like this. And also here also you can adjust 0 to 5000. So I already told you the initial 1000 steps, maybe you will see the more fluctuation. So if you want, you can do it into 6,000 time steps. So 6,000 steps, then you can ignore these 1000 steps. You can make it another 10,000 steps, add to your this 4,000 in order to make 5,000. So okay, just we can make it this plot. So already I made it one plot, so you can copy. So distance, this is the femtoseconds, we converted into picoseconds. So just to remove this, delete that one. Just you can make copy paste. Paste, and you can put Control Z, it will come automatically the same place. So you can make grids, then it looks good. So you can make it somewhat bold, the outside layer. So you can also make independent underline. You can give your color whatever you want. Just I will leave like this. So you can make it 2. So everything you can click, you can make it. Then it will look somewhat good. So make your based on your choice of colors. Just I'm leaving like that. So if you want, you can also change. So violet. So like that, you can make it your own color. So you can arrange it. So you can make N1 to FE, N2 to FE, N3 to FE, N4 to FE. So you can go here, frame, I think you can give none. Okay, if you want to bold, just you select one by one, click it bold. Yeah, this is the things. So you can also arrange this. Increment 0.5. So click bold and 22. Okay, that's all. You can put your name of the system. Just so this is important, temperature and thing. Just copy it. So our system is 500 Kelvin, I did. So this is So Fe-N4C, this is the 3N1, N2, N3, 4 Fe bond. Okay, you can save it now. So this is the distance west time plot. So you can export. So always use JPG. So name so you can save it into the corresponding folder. Just copy the pathway and keep here. So make it somewhere 600. Yeah. I think our figure is saved. This results shows that our catalyst is thermally stable under 500 Kelvin. Okay. So that's all. Next we will see the RMSD time plot. So this is also a very important plot. So actually this is the file, MSD file. So you can see here different kind of parameters. So we want to plot only this time, picosecond. This is square MSD, so square root of MSD. So we are going to plot this one and this one only, not this any other thing. I think these are no need. Okay, so just I will close this. So I open one, this already I made one plot. So that's okay. Just drag our data. So this is our data. So this is the last one, only important one. So just to select this, no need select this one. You can select just to plot. Go to plot line. So you'll get like this. So so why you are coming 10,000 means we have mentioned that two in the port 2 times steps, so that's why you're showing 10,000. So we can make it into 10 picoseconds this. So we can adjust this one 0 to 10,000. So you can also adjust this. So -1, you can also do -2. I think +2. Yeah. This is our system. You can also make it here. This is our RMSD, square root of RMSD West time thing. So you can make also here also grids. So you can also make color, some different color if you want. So already made one figure for this one. Just I will copy that things from here. Just copy this data. So 500. So you can type FEN4 at. This is the RMS device time plot you can use for this your future research. So you can make like this plot and do it yourself. Yeah. So now we can save this, export. So we already saved, so we can go directly there. You can change into JPG. You can type RMSD this time. So mainly I will do these two analysis only, though this is I think very important. So you can also do it yourself. And you will see our RMS device time plot. Yeah, just crop. So this is our RMS device plot. It shows that this is highly stable catalyst under this kind of temperature. So I will share these files for your reference, so you can download it and use it yourself and do your own AIMD calculations. So if you like my content, please like and subscribe and comment and share, and also please click the bell icon for my future update. Thank you for watching. Thank you for your time. Happy computing.